Let's consider another example for DFA minimization. Now in DFA minimization, first step is remove unreachable states, and then second step is write transition table for reachable states. So can we combine these two steps? From given transition diagram, can we directly come up with transition table only for reachable states? So let's see how to do it. So start with initial state. Initial state is A. From A, on 0 we go to B, on 1 we go to C. Now consider B. So we have to mark states which we have considered. So from B, on 0 it goes to C, on 1 it goes to D. We have considered B, now consider C. Now from C, on 0 it goes to C, on 1 it goes to E. Now we have considered this C, next entry is C, and we already have considered C. So consider next entry D. So D on 0 goes to D, D on 1 goes to D. So we have considered D. Now consider C, already considered. Now consider E. E on 0 goes to E, E on 1 goes to E. Now consider D, already considered. D, already considered. E, already considered. E, already considered. So we have come up with transition table which contains transitions only for reachable states. G is not reachable. And in this transition table, remember to mark final states. Don't forget this part. Now practice this method. If you feel comfortable, follow this method. You will save time. If you are not comfortable, if you are confusing, then don't follow this method. Follow the trivial part where you first remove unreachable states separately and then write transition table separately. Do not compromise correctness for saving time. Now we will proceed with writing 0 equivalent, 1 equivalent sets. Now for 0 equivalent, we take non-final states first. So A, B, C, these are non-final states in one group. Final states will be in separate group. So D and E, these are final states. A, B, C, non-final states, they are 0 equivalent. D and E, they are final states, they are 0 equivalent. Now consider 1 equivalent. So we have to check whether A, B, C, they are 1 equivalent. We will start with A and B. So for A and B, B and C, we have to check whether B and C, they are in same group in 0 equivalent. So they are in same group. C and D. So C is here, D is here, they are in different groups. So A and B, they are not 1 equivalent. So they will go to separate groups. Now let's check A and C. So B and C, they are in same group. C and E, C is here, E is here, they are in different group. So first we have checked A and B, they are not 1 equivalent. Then we have checked A and C, they are also not 1 equivalent. Now we cannot conclude by transitivity that B and C are not equivalent. We cannot do this. We have to check for B and C separately. This is what you have to learn from this example. So now we will check for B and C. So let's check whether B and C are 1 equivalent. So C and C, same state, must be in same group. D and E, they are in same group. So B and C, they are 1 equivalent. Now let's check D and E. So for 0, we get D and E, they are in same group. For 1 also D and E, they are in same group. So D and E, they are one equivalent. Now let's calculate two equivalent. This group contains only one state. We have to copy that group. Now let's check for B and C. Now for B and C, C and C, it is same state, must be in same group. D and E. Now we are calculating two equivalent. We have to check whether D and E, they are in same group in one equivalent. So D and E, they are in same group in one equivalent. Right now we are checking B and C. B and C, they are two equivalent. So this group is complete. We have considered this group. Now consider this group, D and E. D and E. So D and E, they are in same group. D and E, they are in same group in one equivalent. So D and E, they are two equivalent. So pi 1, one equivalent set and two equivalent set, they are exactly same. Even if we calculate 3 equivalent, 4 equivalent, we will get same set. So we stop and we can conclude that states B and C, they are equivalent states. States D and E, they are equivalent states, and we should merge them for minimal DFA. So this part is only for understanding purpose. This is not mandatory. Don't waste your time. This is only for only for understanding. So we have to take three states. First is A, then BC, and then DE. So for initial state is A in given DFA. We mark this as initial state. Now for transitions of A on 0 goes to B, B is here. A on 0 goes to B. A on 1 goes to C, C is here. So A on 1 goes to BC. Now for transitions of this state, B on 0 goes to C, C is here. So BC on 0 goes to BC. Even if we consider C, we will get same transition. C on 0 goes to C, C is here, we get this transition. Now for transitions of 1, B on 1 goes to D, D is here. So BC on 1 goes to DE. Now for transitions of DE, D on 0 goes to D, D is here. Even if we consider E, E on 0 goes to E, we get this state only. For transitions of 1, D on 1 goes to D, D is here. And even for E, E on 1 goes to E, E is here. Now we have to mark final states. So final states in given DFA are D and E. We have to cover all the final states. Now for D and E, we mark this final state and we cover all the final state. We have to cover all the final states. So this completes the DFA. This is minimal DFA for the given DFA.